afternoon, everybody. Welcome to our second webinar that we're going to go in depth on design elements of an evaluation. The PowerPoint that we have for you, that we're presenting to you today, this will be available for download this afternoon so that you can review the notes on your own and access the links anytime you want. Just a quick reminder, if you have any content questions, please submit them through the chat box and we'll answer the questions at the end. If you have further questions or comments, please include them in the evaluation form at the end, and we'll address those questions in the next webinar and in a written FAQ document. Also, if you have any technical questions that you aren't able to resolve on your own, please send an email to our tech guru, Nathan Archer, and his email is narcher@fcrr.org. That email address is also in your email invite for this webinar, so you can find it there if you can't remember what I just said. So we're going to get started here right away. Hopefully, for those of you who are able to attend our overview session, you got a chance to think about logic models and to think about the logic model for the particular professional development evaluation that you may be creating. You got a chance to talk to your team about it and have that logic model now in front of you, so that as Dr. Kuhn talks about setting up the design and the methods of an evaluation of professional development, you can think about how that applies to your specific design. Okay, so thank you for all of you who attended our overview webinar. Thank you for your helpful feedback. We got lots of great responses, questions, and comments in our evaluation at the end. And between that day and today, we've adjusted some of the future webinars in response to your questions and concerns that are within the scope of our content and technology. We also removed all future instances of audio recordings, so we shouldn't have that technical difficulty popping up. We also got the understanding that there's a need for guidance in best practices for professional development. However, there are thousands of studies on implementation of professional development in various content areas and thousands of educational program evaluations. Therefore, to meet our charge of developing a successful professional development program evaluation, our webinar series has the following scope. Our main goal is to show you evaluation designs that allow for causal inferences. Those are randomized controlled trials and quasi-experimental designs. And the context with which we're putting that in is for examining the effectiveness of professional development. What's out of scope for our purpose for these webinars is other program evaluation designs. There are many, many other very good program evaluation designs out there, but we are focusing only on the causal inference kind. Also out of scope for this particular set of webinars is identifying best practices for conducting professional development or identifying best practices in systems change. And we try to keep in mind our target audience, which is local education agencies, state education agencies, and researchers who are interested in creating an evaluation of a specific professional development program, and that you have an intermediate level of understanding in effectiveness studies. If you have an advanced understanding of research designs, or if you're certified as a WWC reviewer, this information is likely redundant with your current knowledge. Or if you are planning an effectiveness study that does not include a causal design, this webinar series may not provide sufficient information for you, although we have now tried to include some references to resources on some related topics. Finally, just a note about some of the examples that we use. At the overview session, we asked participants to list some of the professional development content that they were interested in evaluating, and a majority of you responded that you had interest in the impact of professional development on K-12 student academic achievement outcomes. We use quite a few examples of academic achievement outcomes throughout. However, we do keep in mind some other outcomes and think that the concepts can be generalized to behavioral outcomes or to pre-service professional development. So before Dr. Kuhn gets started, I see we have a question. about the PowerPoint. So we will be sending out a link to the overview presentation and a link to this presentation, and after each webinar, links to those so that you can download them. And eventually, all of this will be available for anybody to, it'll be available archivally for anybody to access. So please plug in your questions into the chat box as we go through, as you think of them, and we'll answer them at the end.
Good afternoon, everyone. Thank you, Adria. This is Sharon, and we'll spend the rest of this afternoon talking about planning the design and building on the topics that we talked about in the first webinar, which is essentially talking about the What Works Clearinghouse evidence standards and other aspects of quality evaluation design and considerations for as you go forward. Before we get started, as we did in the first webinar, I'd like to spend a few minutes just to be clear on the distinctions between the clearinghouse standards and additional qualities of strong studies so that we cover all of our bases. So remember that the WWC design standards focus on two distinct groups, a treatment group and a control group. For RCTs, the concern is whether or not you have low attrition for both the treatment and control groups. For QEDs, you want to make sure you have baseline equivalence between treatment and control groups. For all designs, you want to make sure that the contrast between the treatment and control group measures the impact of the treatment. It's important to make sure you have valid and reliable outcome data used to measure the impact of the treatment. You don't want to have any confounding factors in your study, or you don't want your outcomes overlined with the treatment, and you want the same data collection process for both groups. So same instrument, same time of year for both groups. And then in terms of additional qualities of strong studies outside of the clearinghouse evidence standards, as we talked about yesterday, it's important to have pre-specified and clear primary and secondary research questions, which was one of the activities that you worked on. You also want to think about the generalizability of the study results, and that's not included in the clearinghouse standards. Clear criteria for your research sample eligibility and matching methods. Things like power, in other words, making sure that you have a sample size large enough to detect meaningful and statistically significant differences between the treatment and control groups overall and for specific subgroups of interest. And that your analysis methods reflect the research questions design and sample selection procedures. And then a clear plan to document the implementation experiences of the treatment and control conditions. And in other words, the fidelity of your implementation. And so we're not going to talk about fidelity today, but in the third webinar, that will be a focus of the presentation, and so you'll hear more about that. And let me just point out that for those of you that weren't participating in the first webinar, for more information about the topics on each of my slides, there's a source provided. And so in this case, the document that I used to make these distinctions is a document that was produced by DIR, and they do a really nice job of showing what the clearinghouse standards are and other qualities of strong studies, and how those other qualities, while not considered by the clearinghouse, may also indirectly impact your rating if you're concerned about a WWC rating. So just some reminders, again, before we get started. The first question that's asked when reviewing a study under the clearinghouse standards is whether the group membership is determined through a random process. And if it is, it's reviewed as an RCT. So one of the features that the clearinghouse examines when reviewing an RCT is the extent of attrition in the study sample. And again, this is the sample that was defined at baseline. And the clearinghouse focus is on two measures of attrition. One is the extent of overall attrition, that's in the pooled treatment and control group sample when they're combined together, and the other is the difference between the attrition between the two study groups, the treatment and control groups. So starting at the top of the flow chart, on this slide, after answering yes to the random assignment question, the WWC looks at whether the levels of overall attrition and differential attrition meet the attrition boundary. And if they're below that boundary, then the study falls down the no column. And the highest potential rating that the study can receive is meet standards without reservations. And it's the highest rating that's issued by the clearinghouse. And if the attrition crosses the boundary, then the study is considered to be a high attrition RCT or a QED, and then the study has to assess baseline equivalence. The WWC wants to see if the treatment and control groups are comparable, because now attrition is too high, particularly if there's a big differential between the treatment and control group, and there's concern that the results may not support causal statements about the intervention. So working down the right side of the flow chart, we then look at the baseline equivalence of the treatment and control groups. And this is in the analytic sample. This is a sample that's used to calculate the impacts. So these are the individuals who have the outcome data that's needed to calculate impacts and who also have the data that's needed to assess baseline equivalence. If the two groups are comparable, then the highest potential rating that study can receive is meet standards with reservation, because there's still a lot of concern that their causal statements may not be 100% supported. And if the two groups are not equivalent, then the study is rated does not meet standards. So that's just a review of some of the points we covered to make sure that everyone understands some of the key features. So today, given the huge role that attrition plays in reviewing RCTs and the huge role that baseline equivalence plays in high attrition RCTs and QEDs, we'll talk today about attrition and how to strengthen or how to prevent studies from experiencing attrition, and also about baseline equivalence. But for RCTs, we'll also talk about the random assignment process and what researchers can do to strengthen that process to meet WWC standards. And also in cluster level RCTs, those where schools, for example, are randomly assigned to a treatment or control group, and then individuals within those schools, such as teachers or students, are then analyzed. There we'll talk about the kinds of consistency between designs and analyses that the WWC looks for. And then for both designs, we'll talk about confounding factors, whether any of these any confounding factors exist, and whether appropriate outcomes were analyzed. So we'll talk about those key study features. We'll also talk about power analysis, which is not considered by the WWC evidence standards. So turning to RCTs, let's talk about the random assignment process. So the WWC accepts random assignment at any level and at multiple levels. So for example, random assignment of schools, random assignment of teachers, students. When researchers are deciding the level at which the random assignment will be conducted in a study, an important consideration, of course, is the level at which the intervention is implemented. So if you're studying a program that is a whole school program, ideally the RCT would conduct school-level random assignment so that implementation in the study is done in the same way the program is implemented outside in the real world. In other words, this way the evidence that's produced by the study is useful for understanding the effect of the program and the way that, as I mentioned, it operates in reality. It's also really useful because it can help to prevent contamination of the comparison group. So for example, again, if you were studying a school-level program and if you were to conduct random assignment of teachers within schools, such that you had treatment and control teachers in the same school, there's a possibility that the control teachers could end up accessing the intervention and in effect start being treated just like the treatment teachers are. And that will more than likely provide less useful evidence of the effectiveness of that program. So what we need to do then when you're conducting the random assignment is to make sure the units, as I mentioned, teachers, schools, students, are assigned entirely by chance. Make sure that each unit or each individual, depending on the level of random assignment, that each individual has a non-zero probability of being assigned to each study group. So, for example, each individual has a 50% chance of being assigned to treatment or 50% assigned to the control comparison condition. You can also have different probabilities across conditions. So you can assign 70% to treatment and 30% to comparison, or either have consistent assignment probabilities within group, or use an appropriately analytic approach when you're actually calculating the impacts. It can also be very useful to conduct random assignment within strata. So, for example, if you were conducting a school-level random assignment design and the total study sample was going to be 30 schools, and you plan to have 15 of which assigned to the treatment group and 15 assigned to the control group, and you have relatively small sample sizes, 15 and 15 is only 30 schools, the baseline characteristics of the treatment and control schools could actually differ because you don't have enough sample within each group. So if it's important, for example, to balance the treatment and control groups along school achievement, one thing you could do before you conduct a random assignment is divide your 30 school sample into, let's say, 2 groups, a lower achieving group and a higher achieving group, and then conduct the random assignment within each of those 2 strata. And that will help increase your chance that the distribution of school achievement at baseline ends up being comparable across the treatment and control groups. So just in case you have attrition and you need to show baseline equivalence, you'll be able to do so. Another important point to make here is that when you're conducting or calculating impacts, you must maintain the status, the assignment status in those analyses, even if non-compliance occurs. So, for example, if some treatment group members end up behaving more like from what you expect from your controls or comparisons, in that they, don't participate in the intervention that was assigned to them or was offered to them, you still need to keep those individuals in the treatment group when you're calculating impacts. And similarly, if some control group members end up accessing the intervention and therefore behave more like what we'd expect from the treatments, you still need to keep them in the comparison group. So that's important for maintaining the internal validity of the results to support causal statements. But it also, impacts your study design. And, another term that covers that is the intent to treat analysis. So you need to think about that as you design your study. So if you're conducting a cluster-level RCT, the clearinghouse accepts analyses of both cluster-level data and subcluster outcomes, but it's important to be aware of the way the clearinghouse uses the 2 sets of results in your design, so you can plan for this. When cluster-level outcomes are analyzed, the clearinghouse considers that analyses are providing evidence about cluster-level effects. So, for example, in a school-level RCT, if impacts are based on, say, school-level average achievement at follow-up after the intervention was implemented, the clearinghouse considers that analysis to provide evidence about school-level effects, and it does not consider that analysis as providing evidence of student-level effects because the students in schools may have changed between baseline and follow-up, and therefore, the effects of the intervention are confounded with any student mobility effects, particularly if there are differences in mobility across the treatment and control groups. So, to include subcluster outcomes, for example, students, the sample must include the subcluster units that were identified before the results of random assignment were revealed to those who were randomly assigned. So, for example, if you're conducting a school-level RCT and you're examining teacher-level retention, the sample must include the teachers in the schools before the random assignment results were provided to the schools. It cannot include any teachers who joined the schools after the random assignment results were provided, because the effect of the intervention could be confounded with that type of teacher mobility. So related to this is the topic of attrition. So when we talk about attrition, this is something that occurs when some of your sample members that were initially assigned to the treatment or control groups are not included in the analysis because we don't have the key data that's used to calculate the impact. So the WWC is concerned about the overall attrition and differences in the attrition rates between the treatment and control groups. And for cluster level RCTs, as we just mentioned, the WWC examines cluster and, if applicable, subcluster attrition. So, and here, then, for a low attrition RCT, the key data are outcomes. So if it's a high attrition RCT, then we also need characteristics used to assess baseline equivalence. Because remember, if you're talking about an RCT, you don't have to demonstrate baseline equivalence unless you have high attrition. So, and when we think about attrition, we often think about individuals who have dropped out of the study, and that's why we can't get the outcome data for them. But in fact, attrition also includes individuals or units who were still part of the study, but for whatever reason, we couldn't collect their outcome information. So in other words, attrition is essentially non-response to data collection for individuals who are still in the study. I mean, it includes non-response to data collection. And this sort of brings up an important point here, that when you're conducting an RCT, it's useful to collect the data that are needed to assess baseline equivalence. Because if the study ends up experiencing high attrition, you know, as I've mentioned several times, but I think this is really an important point, those baseline data are needed to assess the baseline equivalence so that the study could potentially be rated as meets evidence standards with reservations. So if possible, again, it's good to safeguard and make sure that you can collect the baseline data in an RCT. And of course, if you end up with low attrition, then you don't need to actually use it for baseline equivalence. So some suggestions about ways to minimize attrition in RCTs. First, it's important to make sure that everyone who is involved in the study understands what study participation entails. So if you're conducting a study of teacher professional development, obviously the teachers have to be informed of the teacher professional development program if they're in a treatment group, and both the treatment and comparison groups need to know what kind of data collection, direct data collection, might be conducted with the teachers. But it's also really useful for higher level staff to also be aware of the study. The principals of the school should be aware, and even all the way up to the chain, to perhaps the superintendent and assistant superintendent, to be sure that the study is consistent with their goals. Another useful way of minimizing attrition is to conduct random assignment after participants consented to study participation. And this is, of course, the case for a study where consent is required. And the reason is that non-consent counts as attrition. So, for example, if you conducted the random assignment of, say, teachers, and then asked them about their willingness to participate in the study after the random assignment results, any non-consent counts as attrition and then counts against your study rating. Another suggestion is to conduct the random assignment as close to the start of the implementation period as possible, because this could help to minimize attrition that's due to turnover. So for example, suppose a school-level RCT of teacher professional development program is going to begin implementation this coming year, say this September, and suppose the study team recruited the schools to participate in the study during the previous school year, the one that just passed, and suppose they conducted the random assignment after they recruited them and informed the schools of their study group status before the previous school year ended. So let's say by the end of May or June. Well, this kind of a study baseline teacher sample would need to include all the teachers who were in the schools before the random assignment results were provided. So it would have to include the teachers that were in the schools around May or June. But you know, between May and June, there could be a lot of teacher turnover, or you know, teachers could move or go to a different school, and all of that turnover counts as attrition and against your study rating. So conducting the random assignment, again, as close to the start of the implementation period as possible can be helpful. Knowing that sometimes it's not possible, but again, these are just suggestions for doing whatever you can to minimize attrition in your RCT. So for a QED to meet the clearinghouse standards, it needs to have at least two groups. One group that receives the intervention and another that serves as a comparison group. It's important for a QED to have a comparison group so that we can see what would have happened without the intervention. You cannot simply compare a treatment group to itself at an earlier point in time. Those simple pre, post, or before and after studies cannot meet the group design standards. Other than having two distinct groups, actually two or more distinct groups, there are no additional group formation requirements for QEDs. Group formation can be accomplished through various non-random processes. Groups can be largely created for convenience, for instance, choosing a comparison group of schools that are near your intervention schools, or by comparing schools that volunteer to implement a new curriculum to schools that did not. So you can use other things such as propensity score methods to create a comparison group where you match the intervention and comparison schools on characteristics that are likely to be related to the outcomes of interest. You can also use retrospective data such as a nationally representative data set to compare the outcomes of two groups of interest. So as we've discussed, baseline equivalence must be demonstrated for QEDs and for high attrition RCTs, and this has to be based on the units or individuals in the analytic sample, the ones who are used in the impact calculation. As the name suggests, it has to be based on baseline characteristics, such as a prior measure of the outcome or demographic characteristics related to the outcome of interest. Baseline equivalence is determined by the treatment and comparison group difference at baseline and expressed in standard deviation units. If the if the difference between treatment and comparison group is less than or equal to 0.05, then there is no need to adjust impacts for any of the baseline measures that are examined. But if the treatment and comparison group differences are greater than 0.05 or less than or equal to 0.25 standard deviations, then the impact requires statistical adjustment. And if there is a difference that's greater than 0.25 for any required characteristics, then no outcomes in the domain where that measure falls can meet standards. So, for example, in a reading domain that includes 3 reading outcomes, if one of those outcomes differs by more than 0.25 standard deviations across the treatment and comparison groups, then none of the other outcomes that were measured in the reading domain meet standards. So, the points on baseline equivalence, I think that's an important takeaway is that it's extremely important that you plan for forming groups that you expect to be able to demonstrate baseline equivalence, because if you don't do that and you actually have differences greater than 0.25 standard deviations, then the whole study and the outcomes are really at jeopardy. So in terms of talking about discussing confounds, a common confound occurs when there is only one unit in one or both conditions. So for instance, a new reading intervention is being implemented in 3rd grade in one school and outcomes are compared to the 3rd grade in the nearest school. In this case, we wouldn't be able to isolate the effect of the intervention because the intervention and comparison schools may differ in ways related to reading outcomes. For instance, one school may have more reading resources, which could be influencing the reading outcomes. Therefore, to decrease the likelihood that there is some factor confounding the results, both the intervention and comparison groups must contain at least 2 units. And this is the most frequent confound that's found in studies. The next type of confounding factor is when the observed characteristics that are not a component of the intervention are a confound if they are completely aligned with one of the conditions. So, for example, if all of the teachers implementing the intervention have master's degrees and all of the teachers in the comparison condition have bachelor's degrees, in this case, it's impossible to separate how much of the observed effect is due to the intervention and how much is due to the higher level of education of the teachers in the intervention group. Another type of confound is when the intervention of interest is bundled with some other services that are not intended to be part of the assessed intervention. So, for instance, in a study designed to test teacher professional development, a new curriculum is also provided to the intervention group. In this case, it's difficult to isolate the effect of the professional development because the curriculum changed at the same time. So the WWC would treat this particular study as a study of the combined teacher professional development and curriculum, but the study could not be used to assess the effectiveness of teacher professional development alone due to the confounding factor. Finally, another confound to avoid is a history confound. A history confound occurs when the pre-tests and the post-tests are not assessed at the same time for both groups, such as comparing the change in fall to spring test scores among this year's third graders to last year's third graders. So when pre-tests and post-tests are not assessed at the same time for both groups, there could be something occurring at the same time as the intervention, such as a change in the curriculum or policies, which could be causing the observed outcomes. So therefore, studies must collect data at the same time for both groups in order to meet the standards. The WWC also examines the outcomes that were analyzed to make sure that they're acceptable and reviews the outcomes along a number of features. One is that the outcomes have to have face validity. So in other words, the outcome has to measure what it says it measures. Second, an outcome must have sufficient reliability, which ensures that measures concepts consistently over time and across people. The clearinghouse requires at least one measure of reliability, either internal consistency, temporal stability of test and retest reliability, or inter-rater reliability. And of course, for some outcomes, some of these reliability measures apply and others don't. Another thing the clearinghouse looks for is whether the outcome is potentially over-aligned with one of the study groups. And so let's explain this with an example. Suppose a study is examining the effectiveness of a curriculum, and suppose that the study uses an end-of-chapter test in the textbook that was provided to treatment students and uses that test to assess achievement of both the treatment and comparison groups. And suppose that in the course of the treatment group, using that textbook, the treatment studies students already took the end-of-course test before it was administered by the study. So this outcome would be considered over-aligned because the treatment group was already familiar with the test by the time it was administered for the study's purpose, whereas the comparison group was not familiar with the test. So that would be an example of an over-alignment. So just as the outcome measurement should not be tailored to one of the groups, data should be collected similarly for both groups. So for instance, it's an issue if data is collected using surveys for one group and administrative data for the other. Similarly, using teacher-reported observations for the intervention group and then researcher observations for the comparison group would make the outcome ineligible. So as I mentioned earlier, power analysis is not considered by the clearinghouse in the handbook, but power analysis is an important part of designing a study. So power is defined as the probability of finding a difference when there is a true difference in the populations. In other words, correctly rejecting a false null hypothesis. So several variables influence the power of a statistical test, including the alpha level or significance level that a researcher chooses. So, you know, the traditional level is 0.05, but it could be lower, and if it's lower, then it's more difficult to let's think of what I'm trying to say. Then it requires more power. So the magnitude of the true another factor is the magnitude of the true population effect, the sample size, whether you have clustering of the data, and the extent to which baseline covariates predict the outcome variable. So statistical power should be carefully analyzed in the study design phase to ensure that there is an adequate sample to detect the expected differences between the treatment and the comparison contrast. So researchers should carefully consider what the expected effect may be and how well other covariates may help reduce your variation or reduce the variation in the outcomes. You should also analyze the power ramifications due to the clustered nature of the results if the intervention will be provided at the cluster size. And there's several online tools that can help you do that. An example of which is Optimal Design. It can be used for individual and group level RCTs, and the software takes into account the factors that we discussed on the previous slide, and allows you to estimate the power of your design. So both the software and the manual can be found online at the website that's listed on the slide, and you can play around with that and identify the sample size that you would need in your study. In the fourth webinar, we're going to look at analyzing results, looking at calculating attrition, calculating baseline equivalence, looking at effect size corrections due to clustering of data and multiple comparisons, and then handling missing data. But in the meantime, you can also, as we mentioned earlier, check out some of the resources at the bottom of the slides for more information. Several of the links take you to webinars on these topics, and then the WWC handbook, and then also, as I mentioned at the beginning, the DIR resource that explains a lot of these things in depth. So at this time, I think we're going to open it up for looking at the questions in the chat box.
Yeah. Thank you so much, Dr. Kuhn, and especially for ending on that really in-depth topic of power analysis. So we'll be happy to take your questions. Right now, go ahead and type them into the chat box, and we will read those questions and answer them for you live. If you can't think of the questions now but are going to sit for a little bit, as you turn off the webinar, when you leave the webinar, it will automatically take you to a feedback survey. And we would really appreciate your feedback on everything that we talked about today, as well as if you have any additional questions that you can think of before you log out, please include those questions or those comments in your feedback. It's very helpful for us as we plan future webinars. And again, the PowerPoint slides, we will put those together and send you links to where you can download this set of PowerPoint slides, and eventually we'll compile all the questions if we get any. I haven't seen any questions come through yet, so start thinking about some of the things Dr. Kuhn talked about. Do you have any specific questions or general questions around how you're going to do random assignment if you choose to do some random assignment, how you're going to select your conditions if you're doing a quasi-experimental design? Do you have any questions about looking at attrition or trying to design your study well to prevent attrition? Do you have any questions about baseline equivalence or the domains that need demonstration of baseline equivalence? Do you have any questions about outcome appropriateness, about the confounds that could be preventing you from making causal conclusions based solely on the treatment that you're implementing? And if you have any power questions.
While we're waiting, I will address one question that I forgot to address in my slides that came up about attrition after the first webinar, and the question was whether or not the attrition boundaries had changed or not. And so I went to the Clearinghouse website, and as of when did we have it? Tuesday, when I checked, the attrition standards that are in, the boundaries that are in the handbook version 3.0 still remain current.
So before we answer this first question, I'll remind you for our next webinar, we'll be meeting tomorrow, again at 2 o'clock. And if you have some outcome measures that you're thinking about, look those up and see, look at their validity and reliability, and bring those with you tomorrow and bring some questions that you have about that. So Dr. Kuhn's going to answer the first question.
Okay, so the first question is, can the random assignment occur after the baseline measures are taken? And the answer is yes, because remember, for an RCT, you're not required to have baseline equivalence, but it's helpful to have just in case you need it. So, for instance, the start of the school year, students are tested, and then you randomly assign students to a condition or whatever group you want to assign or plan to assign. That baseline information is still going to be there, and it could serve as eligibility information for students to be, or your units to be included in the study. But if it's not being used for that case, it still is information about your units that can be used later on to document baseline equivalence.
I'm glad you brought that up too. The other thing that we find often as reviewers of studies is that we'll get to the N, so the number of participants at random assignment, and we'll get all the characteristics of those students. But then there is some attrition, and the results that are provided are on the students who are left at the end of the study. And what we call that, those students who are left at the end of the study, is the analysis or the analytic sample. And the students who were first randomized are the randomized sample. And what we often need to do is calculate the what we have to do is calculate the baseline equivalence of those students who ended up in the analytic sample. So it's good to know at randomization what the equivalence looks like, but in order to do the rating, you have to know what the equivalence is of the two groups on the analytic sample. That was a critical distinction we noticed a lot of people didn't always have.
Right. So you have to have access to the complete data set so that you can actually pull out just the ones you need to in the end if you're required to show baseline equivalence.
Yeah. Any other questions from others in the group? Okay, so we have a question. So there's a question here about saying, I assume it is important that participants in each of the groups are not aware of who is in the treatment or who is in the control group, but with professional development, teachers or administrators might very well know who is participating in a training targeted at them. What do we do about this? So in the What Works Clearinghouse, there's nothing said about a blind randomized control trial. It doesn't need to be blind or double blind. As Dr. Kuhn pointed out earlier, if you have some bleed over where some of the control teachers use some of the materials from the treatment, or some of the treatment teachers don't use the materials at all, they still stay in the group that they were randomized to. Also, one of the studies that I brought up at the overview session was a study, it was very interesting that they had the same teacher implement in some of her sections the treatment, and in some of her other sections the control. So they did a really good job of training up the teachers to either implement or not implement the control condition.
Okay, so there's another question. What if a teacher is assigned to a condition and then leaves before the intervention takes place and is replaced by another teacher? Is it okay for the new teacher to take that assigned spot in the study, or would that still count as attrition? What if a replacement teacher like this doesn't have baseline data? If a teacher drops from a study, is there any benefit in continuing to collect outcome data on the students in that classroom? Those are a bunch of different topics, but let's see, we'll try to, they're all good questions. And many of them are covered in the handbook to further, in further detail. But if you have a teacher that drops after assignment, it is attrition. But it depends on the level of your outcome. And so the handbook talks about stayers and joiners. So if it's a cluster level outcome, then there's less of an impact. But if you're actually wanting to have a report on teacher level outcomes, then then it does compromise your random. It could compromise your randomization and does count as attrition. So a teacher couldn't necessarily take the place of that teacher, but if then it switches to a QED and that teacher joins at the beginning of the intervention, and then you have baseline data on that teacher, then you can show baseline equivalence. So there's a lot more to the question that we can actually directly answer, because it's all about, is it going to be rated as an RCT? Because if so, then you also, as I said, have to look at what level the outcomes are going to be examined, and if other teachers drop as well, and your attrition then gets so high that then you need to switch to a QED. So it gets really complicated quickly, but we can certainly, when we do our FAQ, kind of break this question up into pieces and direct you to the resources that can help answer those questions, because there's all these different scenarios that would be involved in giving a complete answer.
Yeah, that's a very multi-layered question.
Yeah.
And it sounds like some people have experienced these kinds of difficulties before, and they're all very important to look at. So we have quite a few questions, and I really appreciate those questions. What we're going to do is copy them all down and prepare responses to them by looking back at the handbook and pulling up some resources for you for these, and we'll create that written FAQ document. So please continue to keep submitting those questions. We will turn off the audio but leave the webinar running for a few more minutes, and we will try to get back to you on these tomorrow or at the next webinar session 4 or 5 next week. Thank you so much for joining us today, and please make sure you fill out that feedback form.